e-learners. Make sure I do the right presentation. Yes. And we are recording, and here we go. Thank you. I spent 5 minutes on my hair. No, I didn't. All right, sorry for the, and unfortunately it's going to be that way. So we did all the introductions yesterday, correct? We're done with that? Yes, sir. All right, now we're going to have to learn how to do this switch to, you know, a casual messing around. I love that, right? We got to be able to like turn a switch and go like, okay, game's on. I mean, game's on. Just some advice to you is, you got to really resist the urge. If there's a cute, I always say cute girl, but it could be cute boy, right? If there's a cute girl sitting next to you, you can do nothing but stare at her, and wish that she would talk to you, right? You got to get over that. Like, you got to be able to flick that switch, and you got to be able to say, okay, game's on, I'm concentrating, right? By the time you get to 10th grade, you know, for 6th graders, we make the sit straight, put your hands forward. We do all that stuff. We don't do that to 10th graders, right? We expect you to be able to do that. So we're going there right now. So like your eyeball, you don't have to look me ever as soon as I do presentations. So you got to watch the board. Old kids, you know this deal here. New kids. So every day I'll hand you out a sheet of paper. It's got these boxes. And at the top of the box, it says, like the first one says 1 geometry, then it says 2 geometry. So I call 1 geometry box 1, box 2, so on. I do this for 2 reasons. One, to speed things up and to force you to take notes, right? So that I know that every kid in the class, and then I make sure you're filling this out. So I give you something to help you take notes. I do occasionally have kids say, I hate your boxes, I want to put it in my notebook. If you're that kind of kid, that's fine, right? And I apologize, I should have started this off by saying, nothing that we do today is testable. Right? That's the worst thing a teacher could ever say, because they're like, click, turn off. This is the introduction. This is going to be why we have to learn geometry. It's a good question, right? It needs to be answered. Why are we going to force you into a challenging math course? Right? This class will teach you that. I do this by way of teaching you some calculus. All right. So geometry, right? We'll talk about what geometry means tomorrow, but I'm going to teach you geometry through the process of arithmetic. That's just, hey, your operations with numbers, add, subtract, multiply, divide, right? That's called arithmetic. You learned algebra. Algebra is you have a variable thrown into an equation, you solve for the variable. And then lastly, calculus, which I won't explain to you what calculus is today, but I will show you a little bit of calculus today. And if you ever do take calculus, you'll remember that in 10th grade, hey, I saw a little bit of calculus. All of this will explain why we have to learn geometry. All right, some quick notes. This should be a review. I know all the kids that have me have seen this before. I don't know about new kids. Exponents. Remember, exponents uses something called superscript. Superscript. You don't have to write anything down yet. And it's a way of showing repeated multiplication. So, for instance, what does that mean? Somebody? But what does it mean? X multiplied by itself 3 times, right? It's called superscript because you have script and you got a number above it, right? That's the super part of the script, okay? I can't say what's the opposite of superscript, but there's other types of script. For instance, somebody? What happens if the number is underneath?
Subscript.
Right? That is called subscript. It doesn't mean x to the 3rd or x multiplied by itself 3 times. The other one is called, sometimes it's called sub notation, like submarine, right, underneath. Subscript, right, and it looks like this. If you have 2 triangles that are exactly the same, except one's blue and one's yellow, how do you mathematically distinguish the 2? We don't have colors in math. So what we use is called subscript, and hopefully you've seen this before in Algebra 1. That's subscript. This doesn't mean t to the 1st power. This doesn't mean t to the 2nd power. This means, it means the 1st triangle. This means the 2nd triangle. Now, how do you know which one's 1st or 2nd? You get to pick. In other words, subscript is just a way of identifying same variables. T is the variable, right? So if I have 2 things or 3 things or 20 things that are exactly the same, right? But I have 20 of them, so this one, I give them subscript names. They're just names. Hey, there's John, there's Fred, right? You can literally write words, sentences if you choose, right? So they're just descriptive terms. You're going to see this in science. You're certainly going to see this in math. So superscript, right? That's exponents. Subscript, just a way of naming things. We okay? Right? That's not the hard part. All right, here we go. Here we really go. So remember, I'm going to tell you why we're studying geometry through way of arithmetic, algebra, calculus. All right, box 1, write this down in yellow. Brand new, you never heard of this before. Series, S-E-R-I-E-S. A series is the sum of various numbers. The sum of various numbers. Sum means what? Well, it's more than amount. It means not the end product. The end. What does sum mean? What are you doing when you sum something? Yeah, but what operation are you? Yes, you're doing addition, right? So guess what this means? You're just adding numbers, right? It says various numbers. Well, what various numbers, right? The series will tell you using subscript. Okay? What's it say? Capital S, there's your variable. S for series.
Subscript.
And then the subscript says the first 3 positive, what do you think that word means? Mathematicians are lazy. We say we're efficient, but we're really just lazy. We don't want to write the word integer, so we write int. So this means series. That means add some numbers together. What numbers am I adding together?
Various.
What numbers am I adding together? So what are the first three positive integers? Tell me. That's what it's asking you to do. You're like, why does mathematicians have to make this complicated? Why couldn't you just say add 1 + 2 + 3? I did, right there. So a series just takes some numbers and adds them together. What's the answer? You just did calculus. Congratulations. Right? Remember how I started us off? I said I'm going to teach you something complicated at first. It seems that way, and then when you see, you're like, okay, that's not complicated. But it will get complicated. Okay, so that's a series, right? In calculus, I'm not going to get too far into calculus. Calculus teaches the concept of calculus through occasionally through these things called series. All right, what's the answer? So what do you want me to write?
-1, -2, 3.
And what do we got to do to those numbers?
All added together.
We good? In this kind of inefficient way of writing this, what's a plus and a minus turn into? Just a minus. So how could I write this a little bit more easily? Mike has said, he said it right. He just was afraid to say it loud.
Negative parentheses 1 + 2 + 3.
Well, I mean, this is not wrong, but this is a bit more inefficient, right? A negative and a positive put together is just a negative, right? Algebra stuff. Oh, by the way, what's the answer? This was a little bit harder. Micah says -10, yay or nay? Don't say yay because it's Micah. Is that right? Is it -10? Okay. And 1 - 2 is -3. -3 - 3 is -6. -6 - 4 is -10. Don't get hung up on the answer. Get hung up on what. Okay, I got what you're doing. Right? Are we good? These are series. All right. In pre-calculus and calculus, when series are technically introduced, I'm probably the only math teacher that shows series in geometry. But you will revisit this if you take pre-calculus or calculus. Okay, so it turns out for series, they come in lots of different flavors, but there's 2 main ones, right? 2 main flavors. The first flavor, remember, it said a series is the sum of various numbers, right? The first type are called a finite series. So we're going to take a guess what that means. It's a limited number of numbers. We just did 2 finite series, right? So for instance, the one we just did, there's only a finite number of numbers. There's only 3 of them, right? Guess what the next one's called? Okay. Oh, by the way, there's the answer. Yeah, the other one's called an infinite series. So Here's an infinite series. What does that mean? Goes on forever, right? Anybody know the answer? This is hard. What?
Infinity.
Well, how do you know? How do you, or either one of you both said the same thing. How do you know? They said the answer must be infinity. How do you know?
Because
How do you know the answer here is 6, by the way?
it stops.
No. How do you know the answer here is 6? It's not a complicated question. How do you know the answer here is 6?
It's fine.
How do you know the answer here is 6? When I get louder, it's because it's what it equals. 1 plus 2 is 3. 3 plus 3 is 6. You know it because you did it. Well, how do you know the answer is infinity? Did you do it? Heck no, you didn't do it. Why not?
Is it undefined?
Well, how come you can't do this?
Because it doesn't have all the
Thank you,
numbers.
Wes. Right? You would die before you were done, right? You can't do it. All right. So infinite series are what we're going to concentrate on today, the infinite series, okay? So here's an example. This means the series of odd numbers that are positive. 1, 3, 5, 7. Goes on forever. What do you think the answer is? What happens if you add up all the positive odd numbers? What do you get? What's your guess, I should say? Come on, somebody make a guess. Infinity is the guess. It is a reasonable guess, right? Does anybody think it's an unreasonable guess? That's a bad way of a teacher asking a question. You think it's unreasonable that the answer is infinity? Right? What's the justification that's in infinity? Right? Goes on forever, right? You're always adding another number. Will it shock you if I can prove to you that the answer is not infinity for all infinite series? Right? That's what I'm going to try to do. All right, here's another one. We add up all the negative ones. What do you think the answer is here? If you add up all the negative. Reasonable guess, right? But remember, you're making a guess. I mean, you got to prove that to me. Prove to me that it's negative infinity. You're going to die before you finish your subtraction here, right? You can't literally add up all the negative integers. Okay? This is the one we're going to concentrate on today. What's 1 plus 2 plus 3 to infinity? What's the answer? Right? That's what we're going to look at today. So, that's my normal joke. So the question is, what do we think as a class? What do we kind of think the answer is here? Go ahead, say it. We think it's infinity, right? But you can't prove it to me, right? Nobody out there can add up all the numbers. So in order to do this series, we got to do something else. Luckily, we got something else we can do. All right. So your confidence at this point should be shaking because there's a math teacher up there yelling and screaming, and he's saying, "Are you sure?" Right? Clearly, there must be a joke going on here, something right here, right? All right. So how can we prove this without adding up all the numbers together? I'm going to show you something that will blow your brain. Okay. All right. We're going to use our math knowledge and understanding. So how long have we been taking math? 10 years, is that right? You're in 10th grade, right? Count kindergarten. Some of you learned to add numbers before kindergarten. But we'll settle. 10 years you've been studying math. I'm going to use all of your knowledge to try to prove that it's infinity, or maybe it's not infinity. All right. I'm not going to do that yet. I'm going to show you the technique of proving these things. Here's another series. You see this series? Right? This has a name to it. Don't get hung up on the name. It's a series of adding a half, plus a fourth, plus an eighth, plus a 16th. What will be the next number? Next number. What am I doing each time? I'm adding a fraction that has been not doubled, divided in half, right? Half of a fourth is an eighth. Half of an eighth is a 16th. We good? Right? Anybody nodding off yet? What do you think the answer is? Take a guess. She says the answer is 1. That's ridiculous. How could adding an infinite number of numbers equal 1? You're doing this to infinity, right? That means it never stops. Notice there's no negative numbers here, right? That means you keep adding something. How could the answer be 1? Ridiculous. Math teacher stuff, don't cry. If you had been Micah, I would have done that, but I don't know you yet, so I don't want to. You just crushed me, you said no.
How can I do it?
Because you know how I teach and you know the tricky techniques I have. I've kind of already given it away that the answer might be 1.
Stop the count.
But it's ridiculous that she would say 1, right? I mean, this would never end. Even if you got to 1, there's going to be another fraction to add to it, right? You ready for blown away? Here's what I'm going to do. You got 10 years of knowledge. Last year you took Algebra 1. If I put 2 plus 4 equals 6, can I multiply both sides of the equation by 3 and maintain the equality?
Yes.
Right? We did that many times. In fact, that's how you solve some equations. You divide both sides by 3 or you multiply both sides by 3, right? I'm allowed, if there's an equal sign, to multiply both sides of the equation by whatever number floats my boat. Ready? What's the magic number, smart girl? What? She says, no, that's the answer. What's the magic number and multiply both sides by? Okay. We're going to multiply both sides of the equation by 2. Right? You won't know why I picked 2 until you see the answer. What happens when you multiply the left side by 2? What do you get? Not s squared. S times 2, right? Or 2s. Good? What's 2 times a half?
1.
What's 2 times a 4? Oh, let me catch up with you. What's 2 times an 8?
140.
What's 2 times a 16?
180.
Good. I just multiplied both sides by 2. You see that? You see that? What? What?
Keep doing that.
No. Look at the 2 boxes. What am I pointing out? What's the difference between this one and this one?
It's one shorter than the other.
What's the difference between this one and this one? No. Look what I put the box around. What's the first number? What's the first number? What's the second number? What's the second number? What's the third number? What's the third number? What's the difference between the 2? There's no difference. So guess what this box really is? It's S. This says S is that box. There's that box. So that means I can replace this whole thing with, it says it equals S, so I do that. I got rid of the dot, dot, dot. That was our problem. I can't add forever. So I got to get rid of the dot, dot, dot somehow. This is a math trick. I multiplied both sides of the equation by 2. You can solve this now. Solve for S. What do you do with that S to both sides? Subtract S from both sides. What are you left with? Right? Congratulations, smart girl. I wasn't going to eat that anyway.
No!
All right. The answer's 1. It turns out, we just proved it. It turns out, if you add up all the fractions that look like this, the answer's 1. Now that's just crazy, crazy. For those of you in the big visual representation, square with side of 1. What's the area? 1, right? 1 times 1 is 1. The area is 1. So check it out. A square. The whole thing is the area, right? Half of the square plus a quarter of the square plus an eighth of the square plus a 16th. I could keep doing this forever. This is a visual representation of why the answer is 1. All right? I'm just taking a half of the square each time. The area of that square is 1. That's how you prove this series. You got to do some tricks and some algebra. So I'm using arithmetic. I'm using algebra to do a calculus problem. And supposedly this is going to teach you why we got to get, why we got to learn geometry. Where is that going to come from? Let's see. Boom! All right. So don't panic if you're like, I have no idea why he's saying anything he's saying. I saw the numbers, I understood it, but I don't know what we're doing. That's okay. All right. What was our original question, by the way? What are we trying to prove?
Why we're learning geometry.
Right? And then I said I was going to do that by showing you, trying to show you, is this true? If you add up all the, we call these the whole numbers and counting numbers. Why is the answer infinity, or maybe it's not infinity. Okay? So let's do one. All right, I'm going to give you a new series. I'm going to give you actually 2 new series, but 1 in each box. So here's my new series. This time it's called the alternating series. You don't need to remember that. The alternating series, just you got a number 1, 1, 1, 1, 1. First one's positive, second one's negative. Next one's positive, negative. So it goes positive, negative, it alternates, right? That's the, and it goes on forever, never stops. Anybody want to guess? Do you know this one? I'm very impressed that I actually never had a student who knew that answer, by the way. Anybody want to take a guess what the answer is? 0 is a reasonable guess. Anybody else? Problem with 0 is the guess it never ends. So then we're going to add 1 to 0 and get 1. And we're going to subtract 1. We're going to get back to 0, right? Let's see if we can prove this. And I wouldn't expect you to know how to prove this. Okay. So what are we allowed to do? We're allowed to use any of our knowledge from pre-K all the way up to Algebra 1. Okay? Here we go. You ready? Math trick. Karis, what happens when I add 0 to anything? Nothing changes. So even though I'm going to make it look different visually, I'm not changing anything. Underneath that, I want you to write that. I mean, you got to make sure numbers line up. Make sure your numbers line up. This box 2. So I wrote the same series. We'll call it series 1. And instead of going 1, 1, 1, 1, 1 and alternate the positive and negatives, I'm going to put a 0 to start off. And then I'm going to write that same series, a positive 1, a negative 1, positive 1, negative. Okay? Kara said if you add 0 to anything, nothing changes. So I could do that. You guys remember doing systems of equations last year? One of the methods was called elimination. That's where you stack one equation, you stack another equation, and what did you do to those 2 things? Yeah, but what did you do when you stacked them? You just add the 2 things together. So let's add. Let's add. I mean, we did it last year, right? That's how you solve the system of equation. One of the ways. System of equations, you do this thing called elimination. You're allowed to add 2 equations. Well, let's add. What's S1 plus S1? 2 of them, right? So 2S1. Anybody can see the magic here? What's 1 plus 0?
1.
What's 1 minus 1?
0. 0. 0. 0.
I just added an infinite number of things, and I got to an answer. I got rid of my dot, dot, dots. First time I saw this, I was like, what? How would I even know to do that? You won't, right? Somebody smarter than me came up with this. Hey, I can solve this. Miss Riki, you selected the wrong thing.
I'm going to take the iPad, though.
Hey, wait. So, can we just write this down, or
No.
no?
Is this some sort of fancy?
Seth, don't do it.
I don't know how to make that clear. Yes. No, we're not going to watch you.
You want to bring on?
No.
Oh,
Well,
David,
you
what's on
already-
here?
You already blew our minds today. You totally want
Oh, I'm not done blowing your minds.
You want the documentary on math?
done soon.
No, we won't be watching Mandalorian. Okay, back on track. Let's see, where we left off, we added them together. What do we get? Solve the equation, what do we get?
2S1.
So solve the equation for S1, what do you get? No. I'm solving for this variable S. What's attached to it? How's it attached? How do you get rid of multiplication? Not subtract, it's attached by multiplication. So we're going to divide both sides by 2. So what do you get? You get a half. I just divided both sides by 2. So what happens when you add 1 minus 1 plus 1 minus 1 plus 1 minus 1? What do you get? He said 0. What do we actually get? That's a problem, right? Some kids are like, I don't believe you. There's a method called partial. You have to write this down. Partial sums. So let's see. We're going to do the math. What's 1 minus 1? So I partially solve it. I get 0 plus 1. Minus 1? So what's happening to the series as you go down the line? It's going between what two numbers? It's not between 1 and -1. It's going between 0 and 1. What's halfway between 0 and 1? Half. So it's kind of reasonable the answer's a half. Right? As long as you follow the math, we're good. If you're like, I'm completely and totally lost, that's fine. Right? All right, we'll do one more. Box 3. Notice it says 1, 2, 3, 4, 5. Hey, it looks like the series we're trying to solve, but it's got some negatives in there. So once again, it goes positive, negative, positive, negative, positive, negative. Okay? Like, why are you making me do all this? Trust me, you'll see in the end. Okay, so we'll call this series 2. We're going to do the same trick. What was the trick we used on the last one?
Multiplying by 2.
No, that was 2 times ago.
Start off with a 0.
We just added 0 to this side and write the other one underneath. Okay, so same trick. Same trick. Doesn't always work. This time it works. Same trick. Ooh, this one's a good one.
Yeah.
Okay? What happens when we add this one? Well, obviously you get what right here?
You
2s2, right? What happens over here?
get 0 plus 1.
No, you don't get 0. 1 plus 0 is
1.
-2 plus 1. 3 minus 2.
Positive
You get the thing we just did.
1.
I know what that is. We just did it, the previous box. What's 1 minus 1 plus 1 minus 1 plus 1 minus 1 all the way to infinity? What did you get in the last box? What does it equal? It equals a half. Now, I'm going to throw you an extra step here. I mean, it equals the series that we just did, which we said was a half. Okay? How do we solve this? What do we got to do? Divide by 2. What's half of a half? Quarter, right? So it turns out that that series, we'll call it series 2, is equal to a quarter. I'm not going to show you a visual representation of that one. You just got to accept that that one's true. Okay? What is he doing? Where are we going with this? One more box, we're done. Okay? So series, adding up numbers. Finite series, easy to do. You just literally do the math. Infinite series, rough. This is why people don't like calculus. This is calculus you're doing right now. Okay? We just found that if you add up an infinite number of numbers, you get a quarter. We proved it though, right? Using all of our knowledge from pre-K through Algebra 1. I mean, we didn't even need to do, this isn't even hard math, like the adding, subtracting, multiplying, right? Okay. So let's recap. Series of sum of various numbers. This is the one we're trying to answer. We think the answer here is what, by the way? No, we think this answer is, we think the answer is infinite. Right? We did find the answer to some series. We found out the answer to this one is half. We found out the answer to this one is, okay, so here's the only tricky one. This was the one in elimination you had to be careful at. I'm going to subtract a couple of these from each other, okay? So now we're going to get to the end. All right, box 4. You're trying to answer this one. You don't need to write this part down, not this one. Or do you? What do you think? Yes, you do need to write this down. Sorry. Sorry. So this is the one we want an answer to. Now we're going to get an answer. We want to get an answer to that. And once again, you probably wouldn't pick this out yourself. I want you to write underneath it series 2. You got to line the numbers up. Hey, these kind of look alike, right? Just one is all positive and one is alternates between positive and negative. They kind of look alike though. This time we're not going to add. We're going to subtract. You got to be careful with subtraction. You remember doing this for elimination when you subtract? Anybody remember the trick when you subtract? What do we got to do to all the signs here? When you subtract, what do you got to do to all the signs? When you subtract one equation from another equation, you have to go to all the signs and flip-flop them. You're really just multiplying through by a -1. So this 1 now becomes, okay? This -2 becomes 3 becomes so forth, positive 4, negative 5, positive 6, and so on. This is the one that's messy when you do subtraction. All I'm doing is the technique. Chris, you with me? This is the one that, okay, I will never lecture as long as I'm doing right now. We would never go this long in algebra or in geometry. I mean, it would be 5 minutes, and then we do something. 5 minutes, we do something. Okay. All right, let's subtract. So let's see. The series of the wholes minus S2, I don't know. We just, I don't know what that is. We just write it, right? The rest I can do, right? 1 minus 1 is 2 plus 2 is 3 minus 3 is 4 plus 4 is. You get that mess right there. I still got a dot, dot, dot. Let's see. I thought we were trying to get rid of the dot, dot, dot. We're almost done. Would it be okay to get rid of all the zeros? Not change anything? Yeah. So that's what we really get. I got to do this quickly. Okay, stop writing. Watch the board. We had more time. We could finish this and you'd write down. Okay. It looks like we've made no progress. None. In fact, I've made worse progress. I made the numbers bigger. But take a look at the numbers. What did I really just do? What did I really just do? I took this thing, which equals what? It equals that word right there. This equals that word. I took those numbers and I multiplied by 4. So let's just multiply by 4. If that is the same as that except multiplied by 4, then it's that multiplied by 4. And check now what? I don't have dot, 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 and I can solve that sucker. I'm going to do it for you really quickly. You ready? I'm going to move this to the other side. That would give me what on this side? If I take 1 away from that, it leaves me with
3.
leaves me with 3. And then I know what S2 is. Look at your box that had S2. What does that equal? What's series 2 equal? Equals a half. I'm sorry, a quarter, right? Divide by 3. That's 1/4 times 1/3. All right, I'm just going to divide both sides by 3, and I get negative 112. So we found the answer. There you go. Yay! You add up all the numbers, you get negative 112. You did it. Congratulations. Why am I being sarcastic? No, you're done. The answer is negative 112. Why am I being sarcastic? It's not infinity. You told me you add up all the numbers, you get to infinity, right? We just did it. We got negative 112. Look at this and tell me why I'm screaming. Look at the numbers. I'm screaming even louder now. Look at the numbers and look what the answer is and tell me why I'm screaming.
How did you get negative in effect?
That's what he's saying. He's saying, think about this. If you add up nothing but positive numbers, how could the answer ever be negative? Another one. Are there any fractions here? How is it possible to get a fraction if you're adding whole numbers? Further, that means the numbers never stop. And the numbers are getting what? Bigger or smaller?
Bigger.
You tell me if I add a trillion, I get negative 1/12? We got a problem, right? There's a big but here. We got a big problem here, right?
This is nonsense and worth 0 marks. Or less. This is not mathematics. Don't use it, otherwise you'll burn in mathematical hell.
Something is wrong. We added up all the numbers. We did not make a mistake, by the way. We added up all the numbers. We got negative 112. Somebody's been lying to you. Some math teacher has taught you bad math. I'm making a joke here. Something is wrong with our knowledge. We added up all the numbers. We got negative 1. This is a huge, huge problem. That's why we teach geometry. Nothing is ever proven to you until geometry. Somebody taught you something that's wrong, and you never question them. Starting to, and I was part of the problem too. Starting tomorrow, we start from scratch. Geometry is about proving things, not accepting things. When you accept things, you get bad answers. We will prove everything in geometry, almost everything. There's a couple things that get proved into a calculus. Okay? Tomorrow, I need you to bring your compass. You know which one that one is? The one that you can shank people with. Don't shank anyone with it, right? The one with a little sharp point on it. I need you to bring that, and I need you to bring, we in geometry call it a straight edge. It's a ruler, right? If you have a protractor, right, here's your compass, right? Sharp, I'm not joking, you gotta be careful with these things, right? You can hurt yourself or someone else, so be careful with these. But bring your compass, your protractor. I will issue you books tomorrow. We'll have the clipboard. My clipboard?
I'm not going for it. Don't look at it.
Where? Did we all fill out the clipboard? Okay. We get out of here at 54 plus 2 minutes. That would be 56. And it is. It's time to go. That was loud.
Have a good day, Mr.
You as well.